Good morning to one and all. Today we are going to discuss lecture number 55, solved problems in module 4. Okay, the question, problem 1, a three-phase star connected alternator supplies a load of 1000 kilowatt. Okay, 1000 kilowatt at a power factor of 0.8 lagging with a terminal voltage of 11 kilovolt. Its armature resistance is 0.4 ohm per phase, while synchronous reactance is 3 ohm per phase. Calculate the line value of EMF generated and the regulation at this load. Okay, this is the problem. Now, solution. In solution, first go through the problem. A three-phase star-connected alternator supplies a load of 1000 kilowatt at a power factor of 0.8 lagging with a terminal voltage 11 kilovolt. Its armature resistance is 0.4 ohms per phase. Okay, and the synchronous reactance, that is armature resistance RA equal to 0.4 ohm per phase, and synchronous reactance XS equal to 3 ohm per phase, and the power value supplies the load of power P equal to 1000 kilowatt, and power factor cos phi equal to 0.8 lagging, 0.8 lagging, and with a terminal voltage VL 11 kilovolt. Terminal voltage, the other name of terminal voltage will be a line voltage. Okay, line voltage 11 kilovolt. Now for three phase load, for three phase load, power P equal to, this is the power, root 3 VL IL cos phi. Now substitute all the parameter. Power 1000 kilowatt, 1000 into 10 power 3 equal to root 3 into VL 11 kilovolt, 11 into 10 power 3 into IL cos phi 0.8. So therefore IL equal to how much? Can anyone give me the reply? IL equal to line current. IL equal to how much? What is the value? IL. Please unmute your mic and please give me the reply. IL equal to, what is the parameter? You got a 65.
65.60, sir.
Good. 65.6 ampere. This is line current. Now we go through the problem. It is star connected. So in star connected, the line current equal to phase current. Phase current. This phase current is nothing but IA. Okay, armature current IA. Therefore, we can write armature current IA phase equal to 65.6 ampere. 65.6 ampere. Okay, next. Now you have to find the EMF generated, because you see the problem. Calculate the line value. Line value means EL. You have to calculate it. EMF generated. Right. We know that the EMF generated per phase, E phase equal to square root of V phase cos phi IA RA whole square plus V phase sin phi. This is lagging power factor. Lagging means what is the symbol I have to put? V phase sin phi. I have to put plus IA excess whole square. Okay. This V phase, from this equation, this is star connected, so we can calculate the V phase. Okay. So V phase is equal to line voltage divided by root 3. So substitute it. 11 into 10 power 3 divided by root 3. Therefore, how much V phase? Can anyone give me the answer? V phase. V phase how much? Anyone?
6350.85.
Good. 6350.853 volt. Okay. So this value you have to substitute in your formula. In this formula, square root of V phase cos phi IA RA point whole square plus P phase 6350.53 into sin phi. What is the parameter for sin phi? How much? Because as per your question, cos phi equal to 0.8. Okay. So what happens sin phi? How much sin phi?
0.6.
Good. 0.6. So here 0, 0.6 plus IA value 65.6 into excess value 3 whole square. So please give me the answer. E phase. E phase. Please give me the answer.
Sir, 6491.47.
Good. 6491.47 volt. Okay. This is E phase. EMF generated per phase. Generated per phase. That is nothing but E phase. Okay. Now, first subdivision as per your question. Your question denotes calculate the line value of EMF generated. Okay, calculate the line value of EMF generated. So to calculate line value, generated. This is star connection. So in star connection, the line voltage is equal to root 3 into phase voltage. Similarly, E line equal to root 3 into E phase. Okay, therefore E line equal to root 3 into 6491.47. Now can you please give me the reply? E line how
So
much?
11.24 kilovolt.
E line equal to 11 point Okay, this is line value of EMF generated. Okay, and what is the second subdivision as per your question? Calculate the line value of EMF generated, which we have calculated 11.24 kilovolt, and now you have to find out the regulation. Okay, that is my second part. Regulation formula. Regulation is nothing but voltage regulation. Regulation formula: percentage regulation equal to E phase minus V phase divided by V phase into 100. Now substitute all this parameter. E phase value, which we already got it, 6491.47 minus V phase, it is 6350.853 whole divided by 6350.853 into 100. Now give me the answer. How much percentage?
2.2.
2.21. 21. Good. Percentage regulation is equal to 2.214 percentage. Okay. Okay. The problem is very simple. Okay. Now we are going to do second problem. Any doubts? Any doubts in this problem, students?
No, sir.
Okay. Second problem. Problem 2. This is very simple problem, but you have to know the fundamentals. Okay, you are going to recollect the concept which you studied in your basic electrical engineering and electric circuits like that. A 600 kilovolt ampere 125 volt alternator connected in delta is reconnected in star. Calculate its new rating in first subdivision volts, second subdivision amperes, third subdivision kilovolt ampere. Kilovolt ampere. Solution. You see this problem. A 600 kilovolt ampere 125 volt alternator, it's connected in delta. Okay, it's connected in delta. So delta connections, you people are familiar about the delta connections. There are 3 windings are there in delta. Okay, there are 3 windings. These windings will be connected in delta connection. Okay, and each point, each terminal, there are only 3 terminals in delta. Okay, so there is no neutral point. There is no neutral point. So this is R phase. Y, this is B phase. Now here they are applying, this is line voltage VL equal to 125 volt, 125 volt, and the current, when you apply the voltage, the current flows, that is line current, but in the winding the current flows will be phase current. Okay, phase current. So as per the basic information, that is fundamentals of delta connection, so I can write in delta connection, delta connection, line voltage V line is equal to V phase, V phase, V line is equal to V phase. So how much it is? 125, 125 volt. Okay, but current, you don't know the current. Okay, current you are not having. Okay, now how to calculate the current? How to calculate this current? So current will be, we know that power, right? Power formula, power P equal to, this is 3 phase, root 3 VL IL. Here power factor will be unity. Okay, no power factor, it will be unity. So power equal to root 3 into VLIL. So how much power value? It is given, right? 600 kVA. 600 into 10 power 3 equal to root 3 into VL 125 into IL. Therefore, what is IL? Can anyone tell me the IL?
So 2771.28.
2771.2813 ampere. Okay, this is IL. Okay, in delta connection, okay, in delta connection, the line current equal to root 3 into phase current. Okay, so from therefore phase current I phase is equal to IL by root 3, which is equal to IL 277.2813 divided by root 3. So what is the value? I phase, I phase, phase current. What's the phase current?
1600, sir.
1600 ampere. Okay, 1600 ampere. Okay, so in delta connection, the line voltage equal to phase voltage. Okay, this is formula number 1, and current formula, line current equal to phase current, root 3 into phase current. These are the two formula in delta connection. This is my procedure number 1. Okay, so you are having the power, voltage they are applying to the machine in delta connector. When they are measuring it, at that time they are calculating the phase current 1600 ampere. This value will be 1600 ampere. Yeah, measuring. Now the same delta connected, now they are going to reconnect to the star. Okay, star connection, you know that. Okay, note down. Now delta is reconnected to star. Okay, star connection. What is the basic difference between delta and star? In delta, only 3 points are there. That is only 3 terminals. There is no neutral point in delta. Okay, and in star, this is 3 windings. Okay, this is 3 windings, and this all this winding will be connected in this center point will be neutral, which will be connected in 3 phase or Y B. Okay, here only we are applying the line voltage VL. This is IL. The current flowing inside the winding will be phase current. I phase or YB, there will be a neutral point. So in delta there is no neutral point is available. Okay, but when you connected the when you transform the variables from delta to star, the speed will be same. Okay, there is no disturbances in the speed when you are transforming the variables from delta to star connection. Okay, so during that time the machine will be running at a same speed. Okay, same speed. Now in delta connected, what is the phase current ma? Because in delta connected we have measured the phase current, right? Phase current, how much we measured? V phase, how much we measured? It is 125 volt. Okay, 125 volt. Now you have to measure the new ratings of the motor. First rating volt, that is line voltage is equal to root 3 into phase voltage, root 3 into 125. How much? Anyone? Give me the answer. Root 3 into 125.
216.50.
216.506 volt. Okay, this is my first subdivision. Second subdivision, they are informing you to calculate the ampere. Ampere means current. So how to calculate the current? How to calculate the current? What is the formula? Because power, you don't know the power in delta connected. So how to calculate the current? We know that impedance, Z phase impedance. What is the formula for impedance in terms of voltage and current? Impedance is equal to Z equal to ratio of voltage divided by current. Current. Okay. So V phase divided by I phase. So from this we can write I phase is equal to V phase by Z phase. V phase, which we already measured, it is already there. How much? I phase how much? from our delta connected I phase. Why I am writing this formula? When you're transforming the variables from delta to star, this winding impedance, okay, this winding impedance will be same. Impedance is same. So when winding impedance will be same, okay, this winding impedance will be same. When winding impedance will be same, what happens to my phase current? V phase will be 125. Okay, for 125, how much phase current we got it in delta connected? How much? It is 1600. Okay, this parameter we have to write it. I phase is equal to 1600 ampere. Okay, so are you understand my point? Why I have written this Z phase? The reason is that when you're transforming the variables connections from delta to star, the whatever the number of turns which is available in the delta, the same number of turns only available in the star also. Okay, so because of that, the winding impedance will be similar or same. Therefore, I phase equal to 1600 ampere, which we are taking from the delta. So in star connection, the line current is equal to phase current, which is equal to 1600 ampere. Okay, third point, they are informing you to measure the power, kilovolt ampere. So how to measure the kilovolt ampere? What is the formula? Power equal to root 3 VL IL, which is equal to root 3 into VL. What is the VL value? 216.506 into IL 1600. So how much? How much it comes around? Root 3 into 216.506 into 1600. It comes around how much? Students, you got what's the answer?
599.
599.99 into 10 power 3. Okay, so this value you can equate to 600 kilovolt ampere. The unit of power is volt ampere. Okay, so therefore power equal to 600 kilovolt ampere. Okay, any doubts? Any doubts? Please note down the
calculation of I.
in terms of
Sir, calculation of I current, sir.
current, it is the 1600, right?
How, sir?
IL, it is already there, right? It is 1600. That value only I am substituting here.
Sir, V phase will be changed in star connection, sir.
In star connection, the voltage VL is equal to root 3 into V phase, but the IL will be a same, right? It will be a same. You understand this concept? I phase is equal to V phase. How much V phase? Can anyone ask you another? Can you please tell me the V phase? What is the parameter? V phase?
216.5.
No, it is not 216. That is VL. V phase, you see, it is 125. Where we are taking this V phase 125 from delta connector. Okay, from delta connector. It is 125
Yes, sir.
divided by Z phase. Okay. Now
This same, sir.
understand this concept. When you are transferring the winding connections from delta to star, there is no change in impedance. There is no change in impedance. Impedance is nothing but Z. The reason is that the number of turns are wound in the winding. You see here 1, 2, 3. Here 1, 2, 3. Here 1, 2, 3. Okay, the number of turns all the three phases are same in star. Okay, now go to your diagram of delta. Here also in delta 1, 2, 3, 1, 2, 3, 1, 2, 3. All are same. Okay, so because of this similar windings are in star and delta, the impedance value will be same in this concept. Now when your voltage is 125, okay, 125 volt, the phase voltage is 125 volt. What is that I phase? How much I phase? Ashwanand, can you please tell me? When V phase equal to 125, what happens to my I phase? How much it is? We have to return back to our first concept. V phase equal to 125,
1600.
I phase equal to 1600. Are you understand?
1600.
Okay. So that's what I have written this direct value. I phase equal to 1600 ampere. Are you understand? Are you understand this concept? It's clear now? Ashwanand, it's clear?
Little doubt, sir.
Tell